In this section, we're going to go over reflection. So here in our first example, we have h of x equal negative of absolute value of x. So just like in translation, we are going to graph. Since there are no numbers within the function, we can safely say that x can equal to 0. And here is our vertex, or the x-coordinate of the vertex. Just like before, one less from the middle number, so negative 1, and then one more, positive 1. So all we have to do is just plug in the x-coordinate and then get the y values. So our first one is x equals 0. So negative of absolute value of x. And all we're doing is just plugging in to x. Now again, just like before, I mentioned that we should always keep the absolute value just in case we might have a number in the front. In this case, we have a negative. So the absolute value of 0 is 0. Now I changed from absolute value to parentheses because maybe we might in the future have a number. So we're going to distribute this negative to 0. Well, 0 is a neutral number, so it won't be neither negative nor positive, so it's just 0. Now let's do x equals negative 1. So we're going to plug in negative 1 into x. And again, the absolute value of negative 1 is just 1, and now it has parentheses. Then we're going to distribute the negative to that 1, so it makes negative 1. Now our last x value, 1. Same process. Plug in 1 into x, and absolute value of 1 is just the same number, 1, but this time we have parentheses, distribute the negative, so now we have negative 1. Alright, so we got our 3 coordinates. Again, we only need 3 coordinate points to graph. You could do 4 or 5 to be precise, but it's going to be 3. 3 is enough for me. So, negative 1 is right here. 0, 0, and 1, negative 1. So since this is the vertex, the center, that means that it should look like a V. Absolute value graph should look like a V. So here's the right side. And then left side. So we compared that graph with this parent function graph right here. Here's the original, and here's the transform graph. If we compare it, we see that it reflected over the x-axis, or flip over. So we see that the change of these two equations is that it has a negative in front of the function. Again, a negative in front of the function. In the second example, we have m of x equals negative x squared. So over here, I wrote y equals negative parenthesis of x and then square. The reason I did that to emphasize that the negative is on the function, not within, meaning not on the x, but on the function. Just like the last example, the negative was on the absolute value, but not inside. So, since there are no numbers within the function, we can safely say that x can equal to 0. And this is for our vertex. So our vertex. And again, we just need 3 points for this type of function. Alright, so 0 in the middle, 1 less, so negative 1, and then 1 more. So our x values. So, same process, going to plug in these x values into the function. So x equals 0. We have a negative, and then 0 with parenthesis and square. So we do the square first, so 0 squared will be just 0. And then I'm going to distribute the negative. So it's just, again, 0 is a neutral number, so it can't be positive nor negative, so it's just going to be 0. And I'm going to write it right here. Now, we're going to work with x equals negative 1. Plug in negative 1 here. Now you will see why parenthesis is important. So now we're going to do negative 1 squared. So negative 1 squared means negative 1 times negative 1. So I'm going to write it out. So we have negative 1 times negative 1. That would just be a positive 1, but we still have a negative outside. The negative did not disappear. So negative of a positive 1 is just negative 1. Just like that. Now, I'm going to do the same thing. So, x equals 1. So that means y equals negative, parenthesis, 1 squared. So 1 squared is just 1 times 1. So 1 parenthesis, negative parenthesis 1. That will change into negative 1. So negative 1 here. So we got our 3 points. Now, I'm going to use those points and mark it on this graph. So negative 1, right here, 0, 0, and 1, negative 1. So the parent function or the original function was a U shape. So here, I'm going to use these 3 points where 0, 0, the middle point is a vertex. Again, it doesn't have to be precise, but close to it. And you don't have to go all the way down. Usually it helps if you start from the middle when you're graphing. So if we take a look at the 2 graphs and the 2 functions, we see that the negative is in front of the function. And comparing the graphs, we see that from the parent function to the transform, it reflected or it flipped over the x-axis. So there might be a pattern when we have a negative in front of the function. For our third example, we have m of x equals the cube of negative x. So we have negative within the function. It's on x. So I wrote right here y equals parenthesis negative x parentheses to the third power. Just like before, since this case negative x is by itself, meaning no numbers within, we can say that x can equal to 0. So 0 is in the middle of the vertex, so 1 less and 1 more. Now we are going to do the same process, plug it in. So first one is x equals 0. So negative 0 to the third power. Well, negative 0 is just 0. And then to the third power, 0 times 0 times 0 is just 0. So I'm going to write right here. Alright, now we're going to do negative 1. Alright, so now keep in mind it's a negative x. So this negative is from the function. Now I'm going to write negative 1. Close parenthesis and then close another parenthesis because we have 1 on the outside to the third power. So now it's negative and negative 1. So since we have that, negative and negative 1, that's going to become a positive 1. And now it's 1 to the third power, so it's just basically 1 times 1 times 1, which is 1. Now our last one is x equal 1. So again, negative inside, this negative is from the function, and I'm just plugging in 1 into x. So now it's negative 1 to the third power. Now this is the part where we have to be very careful. So it's negative 1 times negative 1 times negative 1. So these two right here becomes a positive 1, but then we have to multiply by negative 1 one more time. So the final answer is negative 1 for this coordinate point. Now we're going to mark the 3 points. So negative 1, 1, 0, 0, and then 1, negative 1. Now if we compare it to the parent function, it just has to look similar, it doesn't have to look precise. So here's our vertex. So I'm going to graph it like this. And then the other side. Alright, now if we compare it to the parent function, which is like this, and in here, then compare with the equation where it's x to the third, and then in here it's cube of negative x, the negative within the function. Now we can see that it flipped over the y-axis, so it flipped. So there might be a pattern if we have a negative within the function. In this fourth last example, we have the square root of negative x. So again, p of x equal the square root of negative x. So it's just similar to the last third example where it was the negative inside the function, the cube of negative x. So again, since negative x doesn't have any numbers within the function, we can safely say that x equal to 0. But just like in the previous video for translation, for square root, so instead of this being the vertex, the middle point, this will be the starting point. So starting point. So that means 0 will be first. And since we are dealing with square roots, that means that numbers that can go inside has to be a perfect square number. So examples are 1, 4, 9, 16, and so on. But we have a situation, it's negative x. And we need to get real solutions. So we can't do square roots of negative numbers and get real solutions. But if you have a negative inside the square root, the radical, you would get imaginary numbers, or complex. But right now, we are focusing on real solutions. So, since we have a negative x, if I pick 1 and plug it into x, that's going to be a negative 1. So what we need to do is we need to change this negative into a positive. So what we're going to do is, in order to change negative to positive, the numbers that we need to plug in are negative numbers, and you'll see your y. So say I choose, instead of negative 1, I choose negative 4 and negative 9. Alright, so first one, x equals 0. So negative 0 inside the square root, and again, negative 0 is just 0, and then the square root of it is just 0. Now we're going to do x equals negative 4. So again, we have the negative from the function, and now it's -4 that we are plugging in inside the square root. So since we have -4, that will change into a +4, and we are able to do the square root of it, which is 2. Same process for x equals -9. Again, negative from that function, plugging in -9, and then our square root. So inside the square root we have -9. That will change into a +9, and since it's a positive perfect square, we can do the square root of it, which is 3. So when it comes to the square root of -x, not only we can only look for perfect square numbers, we have to look for negative perfect square numbers. In this case only. We got our 3 points. Now it's time to graph. Again, this is the starting point, so 0, 0. Alright, -4, 2. So -4, 2. Alright, so -9, 3. Well, it goes up to -8, but we could say -9 is around here, and then 1, 2, 3. So I'll mark it right here. So since 0, 0 is our starting point, so we're going to start here, and then graph, connecting the dots. Alright, so let's compare it to the parent function. So the difference with the equation is that this one has a negative inside within the function, this one does not. If we compare it, we see that from the parent function to the transform, it flipped over or reflected over the y-axis. So again, since we have a negative inside the function, it reflected or flipped over the y-axis. So in summary, here we have the 4 types of function: absolute value, quadratic, cubic, and square root. Now in this column, the negatives are on the function, outside the function, outside the absolute value, outside the parentheses, outside the square root. So based on the first 2 examples, we notice that when there's a negative outside, it's going to reflect over x-axis. So this is the type of answer I would expect to see on the test. Now over here in this column, we have negative within the function, negative on the x, negative inside the absolute value, negative inside the parenthesis for quadratic and cubic, and negative inside the square root. So based on the 3rd and 4th example, we notice that it reflected, so it's going to reflect over y-axis. So again, these 2 are the type of answer I would expect on a test when you're given these type of questions.